Exponents and radicals. Whenever expressions have exponents that are fractions, the expression is representing a radical. The property here is that if you have your base, which I'm just using x as my base, and the power is a fraction with the m on top and the n on bottom, you can rewrite that as a radical. So for instance, if I had the expression 2x raised to the 4/3 power, the denominator in the exponent is the index of the radical. So that means I would be using a third root. Whatever is in the parentheses is what goes under the radical. Now I can write this whole thing to the 4th power. That means put my exponent on the outside, or I can write the 2x under the radical in parentheses to the 4th power. So the denominator is the index of your radical, and the numerator is the exponent. The exponent can go under the radical, or it can go outside of the entire expression. So let's look at these expressions. I have basically the same numbers involved, but they're just in different forms. Here I have the base of 125 raised to the 4/3 power. So that means I have the third root of 125 raised to the 4th power, or the third root of 125 with the entire thing raised to the 4th power. Now for this expression, I know something about 125. Let me go to my calculator here. Because if I want to take the third root of 125, remember the third root is under the math button. If I go down to the 4th option and take the third root of 125, I get that the third root of 125 is 5. So this expression is really just 5 to the 4th power. So now I can raise my 5 to the 4th power to get that this is 625. Now let's look at this next one. The difference here is that my exponent is negative. Well, remember what your negative exponents mean. Anytime you have a negative exponent, it means you need to use the reciprocal of this, really the reciprocal of your base. So this is going to be 1 over 125 raised to the 4/3 power. We just saw that 125 raised to the 4/3 power is the third root of 125 raised to the 4th power, which comes out to 625. So 125 raised to the negative 4/3 power is 1 over 625. Now here I have a negative 125 in the parentheses with the 4/3 on the outside. So here I have the third root of 125, of a negative 125, raised to the 4th power. And remember, third roots are special because we can take the third root of a negative number. Anytime your index is odd, you can take the third root of a negative number. So here we end up with a negative 5 raised to the 4th power. So to raise a negative number to a power, you have to put it in parentheses. And this still gives me 625. Because a negative number raised to an even power will always be positive. Now on this next expression, I need to go back and remember some of my properties of exponents. Remember properties of exponents that talk about how when you multiply and your base is the same, you keep the base and you add the exponents. If it's division and your base is the same, you subtract the exponents. So the base stays at 36, but my new exponent would be 5/2 minus 1/2. It's always the exponent in the numerator minus the exponent in the denominator. So 5/2 minus 1/2 is 4/2. And 4/2 is 2. So here we have 36 squared. Now if that's a very large exponent, I would probably just want to leave it as 36 squared. But 36 squared, I can certainly calculate that to get that this is 1,296. This next expression is a fraction raised to a power. Okay? So it's not the fraction in our exponent here, it's just a fraction as our base. Because our exponent is negative, we can use the reciprocal of our base and change the sign of the exponent. So this is equivalent to 2/5 raised to the 4th power. Now we have to raise everything inside the parentheses to the 4th power. So that's going to be 2 to the 4th power over 5 to the 4th power. So 2 raised to the 4th power is 16, and 5 raised to the 4th power is 625. So this answer is 16 over 625. In these expressions, we need to rewrite these using a rational exponent. So in other words, instead of the radical, the square root symbol or whatever root it is, we're going to use an exponent. So in order to do this, we're going to take whatever's under the radical and put it in parentheses if there's more than one factor under there. So this will be 2x. Because this is a 5th root, this is my index, that 5 goes in the denominator. If I don't have another exponent here or out here, the numerator of that fraction is 1. So the 5th root of 2x is the same as writing, oops, I wrote the wrong number here, 2x raised to the 1/5 power. Now, you do need to put the parentheses there because the 2 is under the radical, so the 2 has to go with that exponent. Now over here we have the 8th root of x to the 3rd power. So x is the only factor under the radical. It's the only factor or term, so that's all we need to have there. The power is 3 and the index is 8. So this would be x raised to the 3/8 power.